So good morning students, 12th standard physics. So in this class we are going to discuss about Lenz law. So it is a continuous of Faraday's law of electromagnetic induction. Whenever there is a change in magnetic flux linked with the coil or conductor, there is a induced EMF produced in the conductor. So that induced EMF, that induced current, it always opposes the magnetic flux. So that is Lenz law. So the direction of induced current is always opposes the cause. So the cause for the induced current is change in magnetic flux. So the induced current would flow in a direction, it opposes the flux change. So the induced current is effect. So the flux change is a cause. So there is a change in magnetic flux linked with the coil or conductor. There is a induced current produced in the conductor. So there is a change in magnetic flux. So flux change is a cause. So due to the cause there is a effect, that is induced current. So the effect is always oppose the cause. So the change in magnetic flux always in opposite direction, that is induced EMF, that is induced current. So that induced EMF epsilon is equal to, that is minus dn pi, that is flux change or flux linkage divided by the respective time. So to represent the its opposite in direction, they are using negative symbol. Then illustration 1 about the Lenz law. So consider a rectangular conductor, that is ABCD. So it is placed in the uniform magnetic field. So consider ABCD, this is ABCD. So uniform magnetic field pointing inwards. So the magnetic field points inwards the plane. So the ABCD is perpendicular to the magnetic field. Then there is no current. So there is no change in magnetic flux. So there is no induced current flows in ABCD. Now that AB is movable. So that AB is a slider, it's pass on. I am pushing AB towards right hand side. So there is a area is increases. So what's my magnetic flux? Pi is equal to PA cos theta. Here magnetic field, then that normal vector, if it is perpendicular, that is pi is equal to BA cos theta. So if theta, what is theta is the angle between magnetic field and the surface. So this is the surface. So magnetic field points inwards. Then what is the direction of n cap? So that is a normal vector. So both are in the same direction. So cos 0 1. So pi is equal to B. So the magnetic flux is directly proportional to magnetic field as well as the area. If area increases, magnetic flux increases. So I am sliding the AB towards right. Then what happened? So there is an increase of area. So increase of area means there is an increase of magnetic flux. So number of field lines passes through ABCD increases. So there is an increase in magnetic flux. So the AB slides to right, number of field lines passes through ABCD increases. Then there is an induced current flows in the circuit. So that induced current should oppose the flux. So there is an increase. So it tries to reduce the production of by producing another magnetic field. For example, so we are sliding towards right. So there is an increase of magnetic flux. That increase is reduced by producing another induced magnetic field, B induced. So that should be in opposite direction. Here the magnetic field pointing inwards, the induced magnetic field due to the induced current is in opposite direction. So that is perpendicular as well as outwards. What is my inwards, what is my outwards? So the field going into the plane, that is magnetic field pointing inwards. If the field come out from the plane, that is magnetic field point outwards. So just see the magnetic field point inwards, that is cross x, then the dot is magnetic field pointing outwards. So both are in opposite direction. So the cause, then effect. So effect is always oppose the cause. So first one over. And second one, so the current flows. So just simply, so this is the cause. I am pushing the AB towards right. So what should be the cause? What should be the effect? So the effect should be opposite to the cause. So it's from right to left. Then the current flow should be right to left. So this is in this direction. So the current flow should be in opposite direction. Simply we can say, so current flow in this direction. So current flow in this direction means, so what is the direction here? So this is in anti-clockwise direction. So current flows in anti-clockwise direction in the first case. And second, I am pushing again. So initial case, I am pushing AB slider inside, that is from right to left. So here right to left, here left to right. Okay, fine. Now, so what happens? So there is a reverse case. So again there is a change in magnetic flux. So I am decreasing the area. So if I change the area, so there is a change in magnetic flux. So the number of field lines passing into the area ABCD decreases. So there is a induced current flows in the circuit. But that induced current produces a opposite magnetic field. So that should be oppose the cause. So cause and effect. So effect always opposite to the cause. So here, so AB slides to left. So there is a decrease in magnetic flux. So the number of field lines passes through ABCD decreases. So the induced current produces an induced magnetic field inward direction. But it is with the direction, that is inward means, so actually the plane, so magnetic field pointing inwards. Due to the reduction of area, again there is a magnetic field produces. So here we are what we do, we are pushing towards left hand side, area decreases, magnetic flux decreases. To manage the magnetic flux, so additional magnetic flux produced due to the induced current. So that is cause and effect in opposite direction. Again simply, so cause is we are pushing inwards the slider AB, so the current flows in opposite direction. So opposite direction means here, so this is, so this one current flows in what direction? This clockwise. Here this one current flows in anti-clockwise. So this is verified using right hand thumb rule. So what is right hand thumb rule? So your thumb shows the direction of current, your finger shows the direction of magnetic field. If current flows from bottom to top, so what is the direction of magnetic field? In this direction. So like that. Again current flows from top to bottom. So what is the direction of magnetic field? Here, this is clockwise. So just applied. So the magnetic field, the current flows in this direction. Then current flows in this direction. So that is clockwise, anti-clockwise direction. So using right hand thumb rule, we can verify the cause and effect. So what you have seen in this class, that is Lenz law. So the direction of induced current is always in opposite direction, responsible for the cause. So cause, what is cause? Flux change. So there is a change in magnetic flux linked with the coil. There is a induced current produced in the coil. So the cause and effect always in opposite direction. To represent that, we are using the negative symbol. So the induced EMF is equal to minus dN pi by dt. So that is magnetic flux. So we have seen one illustration 1. So yeah, the slider ABCD. So initially there is no current flows in the slider ABCD. Now we are pushing outwards the slider. So there is a change in area. So there is a change in magnetic flux. So number of field lines increases. So the current flows in the circuit. So what is the direction of current? That is find out using the right hand thumb rule, or simply the direction, it's outer direction, the current flows in opposite direction simply. Again the slider push towards inside, so current flows in opposite directions. Okay students, thank you.